Hello, everyone. First of all, I'm the local guy. I'm a researcher here in Sofia Antipolis. I'm also the AC rep of Inria, and I wanted to take that opportunity to say how pleased I am to see you all here on the campus. It's really nice to see the entire W3C here. Yesterday we heard from Maureen Claire and from Jean-François Abramatic about the story of W3C Europe. So what they didn't say is that after it was created, Inria also started to have relation between its team and W3C activities. And in particular, at the end of the 90s, several teams at Inria started to look at how we can publish knowledge graph on the web. So first they studied the Semantic Web Roadmap, 1998. Then they worked on the first draft of RDF, 1999. And one of the team was here, was called Acacia, created by Rose Dieng. If we don't know Rose Dieng, I really encourage you to look her profile. She was a brilliant woman. And she created that lab, looking at how we can publish knowledge graph and share them on the web. Now there is a rule at Inria. A research lab cannot be more than 12 years old. When we reach the age of 12 years, we are shut down. And the bet that Inria makes is that if there is still interest and energy, we recreate them. So after Acacia, there was Edelweiss, and after Edelweiss, there was Wimix in 2012, which is the lab I created here. And that's also the year I became SC rep for Inria. And if you make the math, Wimix hit the 12-year last year, so we were stopped last year, and a new version was created by Catherine Faron. And another team called Marianne was also created on the topic of natural language processing for analyzing debates and social media on the web, especially extracting argumentation. Now, Dom asked me to tap into that history and get some example of the work we're doing, and that's what I'm going to do now. So one of the oldest work we worked on is in the domain of robotics. So if I ask Ian here, please Ian, yes Ian, please Ian, fetch me a spoon, please get me a spoon, Ian. Ian is going to move downstairs and go to the buffet, and then he's going to look for the spoon. If you want a robot to do that at home, you want the robot to have the same behavior. You don't want the robot to start scanning all the rooms and then find the spoon. You want it to move to the kitchen. And we do that because we have background knowledge. We know that the spoons are usually found in the kitchen. And so how do we give that to a robot? That's one of the first subjects we studied. So we coupled natural language processing to extract from corpora from the web this kind of knowledge. Where do we usually find tools? And then we represent them using W3C standards, so RDF, so that the robot can use them and move to the kitchen before starting image recognition. And what's interesting here is that the W3C standard, they are used, of course, to access the corpora, to know where the texts are, then apply NLP techniques, natural language processing technique to extract that. We use the W3C standard to represent the output, the knowledge we've learned, but also we use it to share it between robots, which means when one robot has learned where the spoon are, all the robots know it. They share that knowledge instantaneously. Second example I wanted to give you is in the continuation, extracting knowledge from text. We are now training models to extract dedicated structure, dedicated data from corpus. So the idea is that in many companies, many organizations, you need to augment your data from unstructured sources, from text. And so what we've done is we have taken Wikipedia article, and then we take the SHACL standard, W3C, to allow someone to say, this is the shape of the data I want to extract. This is the kind of graph I want to obtain. And we use that to train a language model, SLM, actually, a small language model, because we want to see how a frugal model worked, in order to extract RDF data that complies to this SHACL. So we use the W3C standard for accessing the data, for specifying the shape of the data we want, and for actually representing the output. The entire chain is actually driven by W3C standards. Third example, this time I moved to the cultural domain. So we worked with a small museum you may have heard of, Le Louvre in Paris. And they were nice enough to share with us their database called Joconde. I'll let you guess why it's called Joconde. And this database is very interesting because it contains two sets, the images, which are pictures of all the art pieces we can find in the museum, and all the metadata from the curator of the museum, which of course, as W3C guy, we transformed into RDF. And this dual base allows us to do what some industrial guy, such as Bosch, would call knowledge-infused machine learning. We drive the entire machine learning pipeline with RDF data. How do we do that? We query this data set to generate training sets to recognize concepts. So for instance, I want to recognize if there is a horse or not in the art piece, which could be a painting, a sculpture, a coin, anything. So we use RDF and external thesauri to annotate the image. We use SPARQL to generate the data set. We train system, and then we turn on the inferring mode, and we use it on all the images to predict if we find a horse or not. And we can compare the result of the machine learning prediction with the result of the data plus inferences using RDFS and all, which is nice because we can detect things such as silences or noise in the data. We can detect where the curators say there was a horse, but that's the red image. I don't see a horse on the image. And the machine learning model says, I don't see a horse either. So that's a noise. And we can detect other pieces where the curator never said there was a horse, but there is a big horse in the middle of the picture, so we would like to add it. And that's how we improve the quality of the cultural data. And again, this last analysis is done through a SPARQL query that are comparing the result of the machine learning and the result of the inferences. Let's move to the medical domain. We have an agreement here with the hospital in Nice, which is a big hospital center. And one of the tasks they ask us to look at is the prediction of hospitalization from the result of a general practitioner. So you go to the general practitioner, and can we predict if in 6 months you will be in the hospital or not? And what we looked at is, okay, you can train model to do that. We have enough data to train them. But what we wanted to see is what happened if before we trained the system, we go to the web and try to augment whatever the general practitioner has said with knowledge from the medical domain we can find about the drugs he talked about the disease he talked about the symptom he mentioned. So we augment the account from the general practitioner with web data. And what we show is that in some cases, we obtain a boost, and we are able to boost the prediction because we actually tapped into the web for that. The last example I wanted to give you is with the chemistry domain. So it really nicely mapped to what Matthew was saying, because some of the tools we are using, Matthew already mentioned them. So the chemist here in Nice, they are working on data from mass spectrometers. And so they have built, actually, without even us knowing it, we discovered it a few years ago, they have built a knowledge graph using only W3C standard that merges data from the chemistry literature, but also data from the mass spectrometer they actually have in the lab. So on the plant they just analyze, for instance. Only W3C standard in the back end, and also only W3C standard in the front end, because it's an entire web app that allows them to access it. And the way we are now boosting it is that this web app is based on linguistic agent that is accessing a number of tools to augment the data we can put in the prompt and contextualize the prompt. One of the tools can be the one Matthew mentioned, which is working on bridging different representation of molecular structures. We also access all the schema or vocabulary they are using in their data and augment the context with extract from them. And of course, we end up transforming any question the chemist has in English, well, chemistry English, because don't ask me to explain the question, into SPARQL, which is solved on the knowledge graph, which also allows us to trace where the answer comes from, ground the answer in the knowledge graph and in data. And here we could talk about the tool Matthew mentioned. We could also talk about the interest of standardizing things such as MCP, the model control protocol, to call these tools. All this, I see plenty of opportunities for us to do. Last example I wanted to give you is in the multi-agent system domain. So we have been working for now 5 years on bridging the web architecture and the multi-agent architecture. I did my PhD in 2002 defended a PhD in 2002 on multi-agent system applied to management of distributed RDF. And the idea we've been working on is we believe that what we're doing at W3C, standardizing the AI per media paradigm, is the perfect way of sustaining distributed AI. There is actually a project that is called Hyperagent that has been looking at that and how we combine some of the latest advances in the multi-agent community with the web architecture. And there is a very, very interesting community group at W3C on autonomous agent on the web, looking at the different aspects, and I think we'll come back to that during the panel. But that could be, how do we describe an agent? How do we describe affordances of the resources for the agent on the web? So to summarize what I've been saying, I think there are many opportunities for W3C and the web in the current evolution of AI. I see the linked data as interoperability standards between data-intensive application in general and in AI in particular, not only for the training of them, but for the testing input, of course, but also for representing the output, their hyperparameter, their configuration, the protocols to call the tools, the new methods to correct or detect hallucination. All of them could be discussed here at W3C. We also have seen a renewed interest in W3C standards such as the provenance ontology, because people want to trace where the data come from, how they were obtained for the training or for the output. And in general, having, as Dom mentioned, having metadata on the web to know where the data, how the data were generated, was it manually created or was it a Gen AI that produced that data before I even reuse them for myself for training, would be a very nice thing. We believe that the web platform for is a very good platform for AI distributed architecture, and I will probably come back to that in the panel, but there are plenty of opportunities in working on web or W3C approach for tool access, RAG, retrieval augmented generation, graph RAG, and so on. And I see really all this as a formidable opportunity to lead the web toward its potential of linking every type of intelligence, natural intelligence, artificial intelligence agent, connected by our standardized distributed hypermedia paradigm. There is one last thing I wanted to mention, which is a non-technical, non-computer scientist work, really. It's another work I've been focusing on for the past 3 years now. So last year we published a paper at AAAI, IES conference, AI Ethics and Society conference in San Jose. So AAAI is the American Association for AI. And the paper is a bit different from a paper I usually write because it's really a call for action. It's called Pay Attention, a call to regulate the attention market and prevent algorithmic emotional governance. And it uses more than 70 references from sociology, economics, politics, computer science, of course, to actually express the fact that I'm really, really concerned about the current use of AI and its coupling with the web to capture our attention. I'm really concerned about that. I think it's a topic that also deserves to be discussed at W3C. It's a multidisciplinary topic. It's a multidisciplinary question. It requires looking at the practices and consequences from every domain. And it's also a topic where we could be issuing proposition and principle, and that's what we drafted also in that paper, and I'm really happy to discuss that with you if you have questions. Thank you very much.